Welcome back. In one of our previous sessions, we used the circle and we made with it an equilateral triangular pyramid. Here we go. We went from circle to equilateral triangular pyramid. Today, we're going to continue with the circle, but in a slightly different mode. We're going to use the circle to represent the clock. And we're going to look at the numbers on the clock, which go all the way around. And we're going to clearly identify 12 and 6, 3 and 9. Now, here are the instructions. If you can print out the face of a clock, you can mark a dot over the number 12, over 2, over the number 4, over the number 6, at 8, and a 10, and put it on the edge. So a dot at 12, a dot at 2, a dot at 4, a nice dot at 6, a dot at 8 on the edge, and a dot at 10. Why have I selected those? Well, let's go back. The circle contains 360 degrees, and therefore the clock also contains 360 degrees. The 12 numbers around the clock are evenly spaced out. We actually, in teaching children the time, we count in 5s. So we count 5, 10, 15, 20. That's 20 minutes. 25, 30, 35, 40, 45, 50, 55, 60. 60 minutes in an hour. Which means that the spaces between each pair of numbers is 5 minutes long. So if I go from 12 to 2, I am actually counting the space of 10 minutes. 2 to 4, another 10. 4 to 6, another 10. 6 to 8, another 10. 8 to 10, another 10. And 10 to 12, another set of 10. So that would be step 1, to mark some dots at 12, at 2, at 4, at 6, all on the edge or the circumference, at 8, and at 10. With those dots, you can take a ruler and join the dots right on the edge. So I've done that, and let me show you what mine looks like, so you would know what yours would look like. So here we go. I've joined the dots, but I've actually trimmed the space. I've trimmed them. And what that made for me, I'll turn it on the back, is a perfect hexagon, a regular hexagon with all the sides equal. Amazing, no measurement. All the sides are equal, all the sides are equal. And in geometry, all the angles would be equal too. That's the meaning of regular. Sides and angles equal. So that's our hexagon. So you might have to play this tape again if you want to try it. But with our hexagon, we're going to do some paper folding. So we go from the circle to the clock, use the face of the clock and the numbers on the clock to define our regular hexagon. And the next step would be to do the paper folding. Now, every time I fold the paper, I'm going to make a trapezoid, isosceles trapezoid. So here's fold number 1. Right down the center from 12 to 6. 12 to 6 gives me fold number 1. trapezoid. I can turn it this way as well. Isosceles trapezoid. I know it's a regular hexagon, and therefore I know all my sides are equal. So these two sides are equal. This one is actually equal as well to the two sides, but the base is twice as long as the top. So that's fold number one, right down the middle between 12 and 6. I'll open it up and I'll show you 12 and 6. That's my fold. Now let's do 9 and 3. 9 and 3. Do 9 and 3. Now, what's this one? Oh my goodness, what's this? 1, 2, 3, 4, 5. Okay. So this one has given me, not a trapezoid, but this one has given me a pentagon. So, but I want a trapezoid. So let's not do 9 and 3. So my trapezoid, let's go 10 and 4. So 10 and 4 would give me another trapezoid. 10 and 4. Ooh, there we go. 10 and 4. 10 and 4. Another trapezoid. I can open it up and you can see here's 12 and 6. That's my first pair of trapezoids. 10 and 4 would give me another pair of trapezoids. And what do you think will give me a third pair of trapezoids? Let's open it up and take a look. These were the numbers I marked. So if 12 and 6 gave me 1, 10 and 4 gave me 1, let's see if 2 and 8 would give me another pair of trapezoids. You think? Let's try that. 2 and 8. Oh, yes. Okay, there we go. Another pair of trapezoids. So folding a hexagon in some unique ways can give me trapezoids, and they will all be isosceles trapezoids. Why would they be isosceles? Because we know that all the sides of the hexagon are equal. So when I fold over, any two sides will be equal. The bases would not be equal to each other. One base would be twice as long as the other. Thank you so much. See you soon.